where we left it last time was to talk a little bit about scatterplots and kind of thinking that I don't need to talk a lot about scatterplots for two reasons. This is the first time I've taught this class, so I wanted to know, what you know from the required classes you've had before. And in the Ox book, Seeing Through Statistics in Stat 1200, they do talk about scatterplots and correlation coefficients. So I'm happy to talk about that. I want to tell you a few things about scatterplots that you probably didn't hear in 1200, just because I think you know what a correlation is. And if you've had other psychology classes, we've talked about a correlation coefficient in those things before. But by all means, chime in if there's things you want me to be sure to hit. If you have two variables, A and B, we're generally looking at, and as A increases, the horizontal axis increases, the y-axis increases, that's a positive association. If you think back to, your algebra / geometry courses and how you willfully forgot everything, a fancy name for the y-axis is the ordinate, and a fancy name for the x-axis is the abscissa. The abscissa actually comes to us from Arabic. The ordinate, when you're standing orderly or at attention, you're vertical, which is kind of how I remember it. Negative associations are the reflection of that the more of one variable, the less of the other variable. Generally speaking, when we're looking at scatter plots and we're thinking about predicting something, we put the y variable, the criterion variable, on the vertical axis and the predictor variable on the x-axis. Similarly, if we have no association, as you increase one variable, we notice that we don't increase any other variable. And if you'd like, you can play around with this little link that I indicated here called Guess the Correlation. So let's take a little look at that. I'm assuming you can see this. It's a correlation guessing game. And if you want, you can play with this and you can enter in a sample size, say 100, and say, hey, generate me a sample. So you can see in this one probably that that's an example of a positive correlation. And the reason that I have students play around with this a little bit is you kind of want to get some general idea of an eyeball guess of what a correlation is based on this display. And the reason you want to do that is sometimes the scatter plot will tell you one thing, and then when you calculate the correlation, or when you calculate something called a regression weight, that's a little different. And so that should make you go, do I have the whole story here? So the way this works is you can look at this and say, oh, hey, this is a positive correlation. And well, I know it's not a perfect correlation. I know it's not a zero correlation. So you can come down here and maybe put a guess in. So in my case, kind of looking at that, I might say that's a 0.65 correlation. And then it will tell you how well you did. Well, didn't do very well. That's a 0.4 correlation, actually. And you can generate another one. That's probably less. Oh, let's say maybe that's 0.3. And in that fashion, you can play around. Where I was a little bit better. You can play around with that and sort of get some eyeball guesses of what a correlation looks like. And we can kind of generate new samples. Sometimes we'll get really nice samples, like that's probably a minus 0.7 something maybe. Just guessing. Being wrong in public is all about being an academic, minus 0.77. And it kind of helps you get some eyeballs. So when you take research methods 2 and you're checking your assumptions and you're looking at things, this is rather helpful. I want to also talk to you a little bit about properties of the correlation coefficient as a function of sample size, because I noticed that Stat 1200 didn't talk about this. And strangely enough, when I teach graduate students, they also seem to indicate that they've never heard of this property. Let's take a look at a really small sample size, 2, and generate a number. Well, I've got two data points here. Well, what's the correlation here? Well, the more you go up on the X variable, the more you go down on the other one, and it's perfect. So, my guess here is that it's -1. If I generate another sample, well, I've got 2 data points. As you go up on one variable, the other one goes up. That's a 1. So no matter what I do, so long as I've got any variance on the criterion, any variance on Y at all, my answer is always going to be 1 or -1. And in the case where I have 2 Y variables and they're both the same value, I'm going to see a correlation of 0, or it's not going to be defined. And if I have 2 variables and both the X values are the same, I'm also not going to have a correlation. So that's kind of a weird little mathy thing about, oh, hey, if you're looking at 2 data points, you really can't get a very good guess of a correlation. But the same property also happens if we expand the sample size a little bit more. So notice that I've got a big correlation here. If I try to draw a line through these 3 data points, I've got a steep negative slope. If I generate it again, I've got another really big correlation with a negative slope. If I generate another one, I've got a really positive correlation. In other words, it's a fairly rare occurrence if I have only 3 data points that I would ever observe a weak correlation. So I don't know if you folks ever go down to Speaker Circle and you listen to the ministers preach in Speaker Circle. And I was at the University of Minnesota, and they travel also to Minnesota as well. It's kind of a spring circuit for them. Brother Jed and Sister Cindy were in business. I think Brother Max is now the one giving talks, but they all had stock stories that they would announce to people that would stick in your memory. They're very gifted in that fashion. They would talk about the frat boy who got into alcohol and went down the road to perdition, and the sorority girl who went and fell in with the wrong kind, and so forth and so on. Well, I have a story about a correlation coefficient that hopefully will have this idea stick in your head, because as a beginning graduate student, I was in, we were collecting some data, and the team I was on had a faculty member running the show, and another student was collecting data. And we entered the data and we ran the correlation coefficient, and it was 0.8. And the professor got really, really excited about that. Oh, wow, this would be a really groundbreaking study. But the sample size is too small, so go back and collect some more data. Well, we all got involved in collecting data, and the person who was analyzing the data, I was a beginning graduate student, I didn't get to analyze data at that point. And the next week, the correlation was 0.7. And the professor said, well, that's a nice thing, but it's not great, but still, it's really unusual. Let's get some more data. Well, the next week, 0.6. And at that point, the professor said, well, are you really sure you're being careful enough when you're giving this instrument out? Because we had a correlation of 0.8, and now it's only 0.6. And she swore, yes, yeah, we're doing exactly what we did before. Okay, the advisor gave us a little side eye about that. And the week after that, the correlation was now 0.4 because we collected a lot of data. At which point the advisor said, look, you're obviously not doing this right. And that person was let go from the program. This phenomenon of correlations decreasing in magnitude the more data you collect is called shrinkage, Shrinkage. And I'll add that to the learning objectives for this. So shrinkage is the phenomenon of small samples overcapitalizing on chance and producing more extreme values of a correlation coefficient than larger samples. I'll have more to say in another lecture about correlations for you, but that's one thing that I wanted to introduce to you. Larger sample sizes are better guesses of what a correlation coefficient are than smaller samples. Any questions about that? So when we're looking at two continuous variables, some association questions are useful because they help us make predictions. So I might look at high school core GPA. So that's your grade point average in high school on the basis of all of the classes that you took that were required for admission to the university system. And we then look at the relationship with college grades. That's a prediction we make. The stronger the association between two variables, that is, the more that scatter plot looks like it's falling on a straight line, the more accurate our prediction will be. And we can use positive and negative correlations to make predictions, but zero correlations are not useful. So when you're looking at the news, when you're looking at articles, it's important for us to distinguish association claims from causal claims. So on the left-hand column here, we've got things that you would read in news articles or research articles that make an association claim. Is linked to, is at higher risk for. For example, in England, there's a lot of studies now about vitamin D supplements and whether those will help in not having severe cases of COVID. And there's one study out there, at least from what I'm following, and it only has 80 some odd participants in the control and experimental groups each, and they find a relationship with severity. But again, that's a small sample. The confidence interval around that, the range of true population values may be very large. However, current public policy is don't go crazy. If you take too much vitamin D, it's going to make you sick. But given that most people are vitamin D deficient, if you lead a life like in the winter where you were not out in the sunshine, if you were a person of color, generally speaking, vitamin D is something that you need to look at. It's worse also for old people like me, supposedly. That's why I take a vitamin D supplement. The recommendation is take it now. It can't hurt. It could possibly help, but we don't know if there's a cause and effect relationship. Other terms: is associated with, is correlated with, prefers, is more or less likely, may predict, goes with. Those are all, there's some relationships going on there. Causal claims are stronger. And the way you can think of a causal claim is that it's the outcome of an experiment where you could, sometimes in a kind of a crazy world, manipulate that X variable, that variable on the horizontal axis. And you would then expect to see a change in the Y variable. So prevents, reduces, fights, worsens, increases. Those are all causal relationships. These are some comments from the book. And to me, it kind of goes without saying, but remember, not all claims we see in the popular press are based on research. Actually, not all of the claims we read in the popular press published by researchers may necessarily be based on research. So you can probably, on your own time, Google the phrase power pose. And supposedly the very way that you stand in front of an audience head up, looking out at the audience, perhaps hands on your hips, with your feet, legs spread apart a bit, is going to affect how people see you. And there's very, very little tiny literature on that, and the research does not replicate. But yet, there are those individuals who claim for themselves the title of researcher, and they don't, you know, they make a lot of money giving motivational talks to people, but the research behind it is not good. That's why you need to do your own research. Sometimes when you're talking about a researcher making a claim, they are also not even referencing research that's shady. They're talking about their own personal experiences or their own intuition, or heaven forbid, the things they got taught when they were in school. So the general structure of this chapter is to interrogate frequency association and causal claims using 4 commonly used terms in psychology. This doesn't mean that this exhausts all of the ways that you can be skeptical. So, for example, in the lecture from last time, when I talked about the fact that if you're going to be critical about the concept, that is sometimes an entirely different thing than using the standard ways that are mentioned in your research. You need to criticize perhaps the ethics of the construct, or the fact that there might be other constructs out there that are more productive in terms of a research agenda. So here are the 4 terms. And as I mentioned last time, these should be on your flashcards that you make. You can copy this out. It also is helpful if you take those definitions, those descriptions, and paraphrase them a bit in your own words, because it's your words that count in terms of how you will link one idea to another. So let's take the first one, construct validity. That is a measure of how well the variables are measured or manipulated, and the extent to which that operational variable is a good approximation of the conceptual variable. So first of all, let's deal with the second one first. Is it the case that how much you learn in college is reflected in your grades? I would say probably not. And if you think about it for a minute, if you go back to the admissions book that you had when you were deciding whether Mizzou was right for you, there was some text at the beginning of that that said, well, what you were going to get from an education. And that list of what you were going to get from an education did not correspond to any single class. As a matter of fact, often those statements of purpose say, after you have gotten your degree from the university, you will be able to reason across many disciplines. You'll be exposed to a variety of ways of thinking about things, and you'll be able to organize your thinking about a particular topic in light of those exposures. Well, in a word, what Mizzou and universities in general say they do is to cultivate your ability to reason across classes. Now, yeah, to some extent, classes build on each other. This class, I hope, builds on what you learned from, say, Stat 1200 or Intro Psych. But specifically asking you, how did you connect the idea of a scatter plot or confidence intervals from Stat 1200 to what you learn in Research Methods 1? We never ask that question. And we never interrogate how well those connections were made. Now, there's, to me, substantial reasons to believe that there are substantial inter-individual differences in how well people do that. So I don't know, I've got to cut down on the word so, because I notice when I'm replaying this and making the video, I really hate all of this, my interstitial of that word, but okay. When I started graduate school, well, I'm sorry, when I was in college, I really did not like math. And I went out and I celebrated every class that I thought was going to be the last class. So the end of algebra, hey, I'm done with math. And then when I said, well, maybe I'd like to go to graduate school, I said, well, you'll need to take more calculus. Well, I took some calculus. But when I went to the University of Iowa, they said, well, you'll need another semester of calculus. And okay. And the humor point here was this was back when the Earth's outer crust was cooling, 1979. They looked at the textbook I had for my undergrad and they said, oh, well, that's a really hard textbook. We're going to put you in engineering calculus. And the class size was 75 people. And I soon figured out that everybody in the class already knew calculus. And the reason that they were taking calculus was it was an engineering school, and our migrations of people from other countries were such that they were taking this class because it was easy, because they needed to work really hard on mastering English. And I remember being confused in that class. And maybe, a lot of you have had calculus too. You say, well, all right, so this is chapter 2. How is chapter 2 related to chapter 1? And the TA or the instructor would look at you funny and go, well, because it comes after chapter 1. So what are the ideas? Look, you just have to do the problem set. And I think people in psychology are more prone to thinking about the connections between the major ideas. There's a very nice book called They're Not Them, They're Different, which is a story of really what I think is one of the better uses of research in higher ed, where the researcher decided she wanted to do a study to investigate why so many people in psychology and philosophy and the social sciences did not even consider a career in STEM. So she solicited people who were academically able, good high school grades, good ACTs, and said, I'm going to pay you to take, say, calculus or physics. And you'll get a grade, but I also want you to keep a diary. The upshot of that was she discovered that a lot of success in these STEM courses consisted of doing problem sets and studying for the final. And the people who were in the social sciences were somewhat frustrated, first by the goal of just solve this puzzle, but secondly by the fact that everything was delivered in discrete little packets. So, this is a long-winded way of me to say construct validity needs to be thought of very carefully, because very frequently, at least in education, we say, oh, well, grades, or failing out of the university, or leaving and not coming back, that's our construct validity for success. And success itself might be a quite different thing. Second part of construct validity, how well are you measuring the variable? Well, if you ask only a couple of questions of someone, and then you turn around the next day and you ask only a couple of questions again, it's probably the case that scores at one time are not going to be terribly related to scores at another time. Which is why, if you've taken the Psych 1 pool tests, there are so many questions that seem redundant. They're trying to figure out what a level is, and they're asking multiple ways of talking about the same thing to get an idea of a score that will be roughly the same if they were to repeat it. Construct validity also talks about how well things are manipulated. So I guess the prime example we didn't talk about of concerns about construct validity is we have lots and lots of interventions to help people, say, lose weight or stop smoking. or cut down on their drinking. And often those involve doing something. So for example, I use the Lose It app to try to keep track of weight. The extent to which people comply with that treatment is an important thing to consider when you're trying to look at the construct validity of your proposed treatment. So for example, if you assign me to the food diary condition and I don't do it, or if you assign me to the no smoking condition and have me like snap a rubber band on my wrist every time I think of smoking and I don't do it, that non-compliance is going to show up when I try to evaluate my data. You know, in those particular cases, I might underestimate the magnitude of the treatment effect. So that's kind of the connection of the variables to our construct. Second, external validity. The extent to which the results of a study generalize to a larger population. Now, there's two parts to this, and I really wish that she would have spelled this out a little bit more. First of all, the sample you have is representative of some known population. So in, say, introductory psychology, I might say, I'm going to draw a sample of 200 people for my research. And the very first question out of the gate is whether those people that I got are representative even of the Psych 100 pool. I can tell you a dirty little secret. Or if you'd like, if you're looking for research topics in, say, honors research or research methods 2, if you do a Psych 100 study, it's probably almost never going to be representative of the Psych 100 population. And the reason for this, and I've sort of kept track of this over the years, is, again, conscientiousness plays a great role in this. If you open up your study and start collecting data the very first day that it's open, the people who participate in your study are, well, sorry guys, they are predominantly women. They show up and they do their studies. And toward the end of the semester, you'll find they're predominantly guys, some of whom come in and say, you know, I never knew I had to do a study. And you know, if you've already closed out your study, if you have your participants early on, you're not going to, you will have a group of individuals who are women, score higher in conscientiousness, perhaps better in academic aptitude or academic achievement, perhaps more likely to be in stable relationships, perhaps less likely to be engaging in the unexamined life of, you know, adventures in alcohol and staying up late at night and ordering pizza out instead of studying. And if your data are predominantly later, you're going to catch these problem people. The problem with that, though, is that those individuals are also more likely to blow off your study. They're likely to blast through a web-based assessment fairly quickly. So the very first thing that you need to do is to gather data on the people who did and did not participate in your data, and at least have a few ideas as to whether those people are systematically different. One of the studies we're doing, for example, is trying to look at drunk drivers. We don't tell them that we're identifying them on the basis of that, but based on traffic reports and vital records, we can identify people who have had arrests for drunk driving. And we contact them and we say, would you be interested in coming into an MRI and filling out some studies? And some will participate and some will not. But for those people who don't participate, we say things like, well, I really understand that. That's just fine. Here is a little postcard. Could you fill out this little postcard for me at least? And that postcard will ask questions like, are you male or female? What is your age? And, you know, what is your zip code? And that gives us a lot of information about who refused to be in our study so that we can at least assess this external validity question to the population of individuals that we initially think of. There is, of course, the larger external validity question of how do the people in my study generalize to people as a whole? And here is where I think the book does a good discussion of that latter type of external validity. Later on in the book, you can go in the back of the book and Google the word weird, white, educated, so forth. There are the people who we study tend to be the individuals and the cultures that are easiest to study. See, I can't recall it off the top of my head, but I think industrialized is another one of the words in there. And to what extent does that then generalize to other populations of people? This is a really important issue. I mean, mainly because if populations research is based on samples that are not representative, this isn't going to really help the population as a whole. When I worked for a nonprofit institution while I was a graduate student, they were trying to find out what interventions would be good to help children in elementary school. And there were the standard things in there. So in rural Missouri, rural Midwest, having a breakfast program really helps because the kids are not hungry and they can attend to things. But one thing that surprised me were the responses from individuals from Washington, D.C. or Chicago. And there they were saying the number one thing we need to do to help our kids is to get them off the streets after 9 p.m. And I thought to myself, how very, very strange. I mean, why would a child be out on the streets after 9 p.m.? And well, I was a graduate student at that time in Minnesota, and one of the friends, her initials are Deb Moore, was from Washington, D.C. And she said, Phil, the next time you travel in Washington, D.C., I'm going to take you around. And sure enough, I mean, this was like 10 o'clock at night, and there were little children out on the streets. And Deb was in her own high humor fashion. I said, gee, Deb, I'm a little nervous being the only white person here on the street. She said, that's okay. They're going to think you my lover. But at any rate, that's, we need to think very carefully about who those other populations could be. Very frequently, these other populations are unknown to us. If you talk, for example, with someone my age, there's a lot, this is just me holding forth. I'm still in touch with a lot of people I went to high school with. And yes, they are very, very, very strong conservative voters. But it's not that they're racist overtly. It's that throughout the course of their life, they have seen dramatic changes in their quality of life. So when I went to school, our little tiny little high school graduated about 130 people. Now that same high school graduates 28 every year. And it happened very slowly, 1 or 2 graduates at a time over the course of many years. Farms have been bought up, industrialized farming, confinement animal farm operations exist, and you don't need lots of people to farm anymore. And the farms that are there ecologically pollute the water. I mean, it sort of looks, the little corner of Northeast Iowa I'm from looks like Western Appalachia. Those are people that are different samples. Generalizing the experience that, say, we have here in Columbia to that environment is kind of a big trick for me. Okay, statistical validity. To what extent do the data support the conclusions? And what the book talks about is it's important that you look at how big the correlation is or what proportion of people actually stay up past 2 o'clock in the morning, and look at the confidence interval. and statistical significance. Statistical significance is the odds that the result you could looking at could have been obtained if there is no relationship. That's the statistical significance of a correlation coefficient. The statistical significance of a proportion has to do with the range of values of the confidence interval associated with the given observed proportion that you have. So if you flip a coin and it comes up heads 7 times and tails 3, the confidence interval around that is a confidence interval of values that you could, that the true population proportion could range in. I don't think that the book goes far enough with interrogating the statistical validity of a conclusion, and we'll take that up in another lecture. But for now, I want to sow some seeds of doubt about statistics, particularly if I do my study and I turn around and do it again. Am I going to be so lucky as to get exactly the same people I had? Or might it be the case that I have one person or a very small number of people who are responsible for the statistical significance I find? And if I have one really, really strange person in the data set, that means maybe that person really didn't belong in the sample, so to speak, that I'm talking about. Or it might mean that there's more than one population out there that I should be looking at. And it's important to consider that representativeness. So when I was in grade school, there was one guy who was in my class who's, one of the people I thought was really, really smart. And in math class, the teacher would hand him some books and just say, go work on your own, and I'll talk to the rest of the class. And by the end of junior high, he was working his way through the senior high math. And by the time he was done in senior high math, he was finishing really big, heavy math books. I don't know what they were about. And when he graduated from senior high, he was tested at the University of Iowa, and they came back and said, you don't have to do a bachelor's degree. You can come to a university and we just want you to write a dissertation. Skip everything. Well, Louis was very unusual. He was an outlier. And if you did a sample of our class, he probably dragged our average math achievement up by several standard deviation units. But he was an outlier. And research based on the class containing the rest of us and Louis is probably going to be a lot different than a random sample of other Iowa high schools. The other thing about statistical validity is, say if you're looking at a correlation coefficient, a regression, a correlation, is a measure of linear association. In other words, I'm going to draw a line through my scatter points and use that to measure the strength of the association. And maybe the relationship is curved, or maybe there are other problems with the distribution of X or the distribution of Y, the predictor or the criterion. It's important to look at that if you can, or to be a little bit of a detective, to be skeptical. So inside, the last one is internal validity. To what extent have we the way I think about this is internal validity deals with, are you looking at the system of variables correctly? So the nicest example that she gives here is, if I think one variable is related to another, maybe they're not related to each other, but there's some other variable that's responsible for changes in A and B. This is known as a third variable explanation of an association between two variables. Well, the other issue there is is it the case in terms of its internal validity that I'm identifying the right variables under study? So let's go back. It helps to look at a little picture. Here's our, we kind of draw a new sample until I have one that I like. So here's a scatter plot. And we see there's a strong negative correlation. Let's do an example of a study. Say my criterion is my y variable, my ordinate, is how many spelling mistakes you make while keyboarding, while you're typing. And say my x variable is how fast you type. It could happen that as we're looking at the data, like we find a bunch of people out there, say children who are learning keyboarding, that the fastest people also make the fewest mistakes. And that the individuals who are hunt and pecking their way through type very slowly, and they're also more prone to make mistakes. Well, there's an example of, gee, there's an association there, but should I come to the research conclusion, if you want to type with fewer mistakes, you should just type faster? Well, no, probably what's going on is each of these data points here, the data points down here to the bottom right that indicate high speed and few mistakes, those people are probably expert at keyboarding, at typing in data. And the individuals in the upper left-hand corner are the novices who have not yet picked up the motor speed and they're a little more uncertain of the keys. So that expertise variable is a third variable that explains the association between X and Y. Now, the book talks about the fact that, well, maybe you need to go out and find that variable and then adjust for that variable and everything will be well. But if you want to answer the research question you are really interested in, that is, how is speed related to performance, you can't really answer it with this data set. You would need to go in and maybe manipulate the speed variable for individual people. And you might find then, even if you have your expert people and you tell them, type faster, have some Red Bull, that they will start making more mistakes. And the positive relationship between speed and errors would be revealed. But we can't always just fix it by adding another variable. So I think we'll be able to get through this part, mostly toward the end, and then we'll pick up on looking at scatterplots next time. So if you have frequency claims, some of the ways that you can be skeptical about them is by looking at the construct validity. Should I be looking at students' alumni reports of how much they enjoyed their time at Missouri as a measure of how much Missouri students are enjoying things? Myself, I'd probably say, nah, that's kind of dubious for a couple of reasons. First of all, the alumni who left Mizzou and consent to be contacted for a research study about Mizzou, if they had a bad experience, they're probably more likely to put the survey in the trash. And there's also this nostalgia that, oh gosh, everything was so wonderful. You might not believe it now, but you look back on, oh, my college days, they were so great. And it does not reflect how you're thinking about right now when there's a pandemic, there's social issues involved, there's the daily hassles of classroom, and sometimes instructors are kind of nasty and the university bureaucracy is not nice to people. The construct validity of such a measure might be questionable. Frequency claims for external validity. Did the people who participated in my study, were they a representative sample of even the people I've identified to study? Is it generalizable to other people? If I invite other folks to come to Missouri, will they have the same experiences in this environment? You know, I sit on the faculty council and they're saying in the year, I believe it's 2030, an awful huge drop off in Missouri high school students will happen. And as a result, they need to go out and recruit from other areas. You know, one of the places they have their eyes on is Chicago, for example. Is the experience of hauling someone all the way from Chicago going to be the same as for the people who we currently have at Mizzou? And finally, statistical validity. And here the book talks about the fact that, yes, you can calculate a proportion for a frequency claim, and you can calculate a standard error, and that will give you some bracketed idea of what a likely range of values are. As I mentioned before, frequency claims, though, are also subject to an outlier effect. So maybe you've seen articles, I know I have, of, oh my goodness, somebody had the COVID vaccine and they got sick, or they actually died afterward. And we don't know what happened, but it's invalid to take these man-who statistics or this one single narrative and not consider the fact that there's a whole bunch of people out there all getting the vaccine, many of whom go unreported because good news is boring. So in association claims, again, you have the construct validity issues that we talked about before, and the external validity outcomes, as I've kind of hammered through now 2 times before, and the statistical validity questions. And again, the book does not talk too much about the statistical validity other than, are there associations there that weren't measured, and what's the confidence interval and the standard error of the correlation coefficient. But I have a few more things I'd like to talk with you about in that department. And I try to remember everything I say, but yes, strength and significance are the 2 things that she looks in the association claims. It's important to remember the terms from Stat 1200 when we talk about a type 1 error and a type 2 error. And a type 1 error is saying that there is an association, when in fact, in the population, if you went out and observed all the people in your population, there is no association. The p-value, the probability that your data could have occurred underneath the theory of the null hypothesis, is the type 1 error. So that's an important thing to kind of keep straight. So I'm going to repeat it. A type 1 error, the p-value, is the odds that your data could have occurred given the theory of the null hypothesis. A type 2 error is the odds that you accept the null hypothesis given that the theory, the true theory that's out there, is that there is an association. So if, for example, the population correlation between 2 variables is 0.3, and I gather, say, 10 observations, and that's not statistically significant, I might say, oh, well, the null hypothesis, I'm going to say maybe, I will accept the null hypothesis. That's a mistake. That's a type 2 error. Well, when are you going to use that? Well, when you write grants, you want to be able to tell researchers, people who are reviewing your grant, who are going to give you the money, if it's the case that there's an effect, if it's the case that there's a relationship out here, when I use statistics, I'm going to be likely to find it. So when I write grants, for example, 1 minus the type 2 error is called power. you want to be assured that the study you propose is adequately powered. And if you're looking for magical numbers, I don't know why, but it seems to be standard practice, you want to have power around 0.8. That is, if there really is an association out there in your data and you collect the data, you'll have about an 80% odds of finding it so. Power is always relative to a value. So if I gather 100 people and the true value between two variables is the correlation of 0.8, I'm going to have more power than if I gather 100 people and the true correlation is 0.3. Because I'm more likely to say, oh gosh, shucks, I guess there is no association there. Have you, all right, have you heard of the term power before? I didn't see it talked about much in Stat 1200, that's why I asked. I see we're at time here, so let's call that a day, and I will see you on Wednesday. All right.